back to another Math Your Day channel. So remember, on our last video we did the reflection and the transformation of the exponential function. So let us look at some examples right, of that. Okay, so remember we said we have our exponential given as y equal to k, where k is our constant k, meaning it shifts the graph, or rather it stretches or compresses the graph, right? And then a, of course, is so that we determine whether the graph is an increasing or decreasing function. And then x plus negative c, then the c is the horizontal shift, and then plus q is basically your vertical shift, also known as your horizontal asymptote, right? I didn't tell you that, but the q is also your horizontal asymptote, right? Okay, let us get into it. So let's say we have y is equal to negative 3 times 1 over 4 raised to the power negative x. Okay, so go ahead and pause the video, try this on your own, and see whether you will get the answer that we get, right? Okay, so first of all, we have a negative. Okay, so first of all, let us identify our a. Remember we said, well, if a is greater than 1, then my function is an increasing function, right? So if a is less than 1, also greater than 0, of course, then my function is a decreasing function. So you can see that in this case here, my a is a decreasing function, so my graph has to be this one here, right? Because my a is less than 1 but also greater than 0, you can see there, so meaning I have to take this graph here. So let me just remove this one here. Okay, so make sure that whenever you're trying to sketch the graph of the exponential function that is given in this form, try to make sense of the function first before sketching it, right? Okay, so meaning in this case we're going to have our function we have our function look like that. Okay, so another thing is you can see that here, okay, we have identified my function as that. Now I can see that, okay, here I have a negative, right? I also have a negative. So what does that mean? Well, it means that we are reflecting across the x-axis, so meaning that my function in that case will be something that looks like that, right? So because I'm reflecting across the x-axis, right, so meaning I can remove this one here. Well, I can remove that one, so meaning my function now it's something that looks like that, right? And then another one is we are reflecting about the y-axis. So when you're reflecting about the y-axis, therefore my function is we are reflecting across or rather about the y-axis, and hence my function in that case will look like that. So meaning I can remove this one here, and hence my function is something like that. Okay, so now from the mother graph you notice that, okay, here I have 0 and 1 always from the mother graph, because my mother graph is given as y is equal to 1 over 4 raised to the power x, right? So meaning my graph is something like that. Okay, so you're gonna sketch this one here, right? My mother graph, in that case here we have a negative, so let's say it just passes this point here. Okay, and then here you have 0 and 1, rather 0 and negative 1, because you have a negative there, 0 and negative 1. So in this case now you can see that, okay, I'm multiplying everything by 3, so that will mean my new y-intercept will be at 3, right? So meaning my function will be something that looks not a straight line, make sure it's a curve. Okay, something like that. Yeah, not necessarily a curve, something like that, because we said it stretches whenever you open, whenever you increase the k value, the graph stretches, right? Yeah, you kind of like take this as a rope, right? You you kind of like open this rope, meaning your graph would be something that look like somehow a straight line but not a straight line, right? So now we have here 0 and -3, right? So that is how you can play around, or not play around, but analyze your graph first before sketching it, right? So it is very important. But again, if you do not remember all these things, it's fine. The other way of doing this, you can basically do the box method, right? I don't even know what method is it, but I'm just going to call it the box method. So you can just put all your input values as well as your independent variables, right? Meaning your x values as well as your y values. So let us see what I mean by that. So I'm going to put a box like that, and then on my left hand side I'll have my x values, right? On my left hand side I'll have my x values, on the right hand side I'll have my y values, right? But that makes sense. And then what I'm gonna do is I'm gonna start from the negative x values. So let's say from -3, -2, -1, 0, 1, 2, and then 3. Okay, so what I'm gonna do is you're gonna take your calculator, right, and then plug in the -3, which is my x, in this point here, right, and then plug that on your calculator. So you're gonna say, well, -3 times 1/4 raised to the power negative times -3. Make sure you plug this on your calculator. Make sure to plug this on your calculator. Like include the negative, the negative signs, right? Include all the negative signs. You should get an answer of -3/64, right? Then if you plug in -2, you'll get -3/16. If you plug in -1, then you'll get -3/4. If you plug in 0, then we're getting -3. -3. If you plug in 1, then you will get -12. If you plug in 2, you will get -48. And then if you plug in 3, +3, you will get -192. Okay, so now let us try to sketch this function here. Now I'm gonna write my Cartesian. Okay, so now you can see I have -3, -3, -2, -1, 0, 1, 2, and then 3. Okay, so at 0 I have -3, so I have -1, -2, -3. Well, let's say this is my -3. Well, this is not drawn to scale, so yeah. So I have here -3, and then at -1 I have -3/4. So that doesn't matter where you put it in. All it matters is that I have a negative x value. I also have a negative y value. So that means that whatever I put in, it has to be on my third quadrant. So it doesn't matter where you put it. I know this is 1, and the -3/4 will be somewhere there. It doesn't matter. And then you can see that it keeps on decrease, or rather the y value keeps on going up. So as I go to -infinity, the graph reaches 0, right? The graph will reach 0, so meaning my graph will start from this point here, and then you join all these dots, join all the my goodness. Okay, see the thing of not drawing to scale, but we'll understand, right? Okay, let's say the trees here. Let's say 1, 2, 3. Yeah, let's say the trees there. That's too far. So something like that. There you go. So yeah, to 1 we have 12. right? So here at 1 we'll have -1 and -12. So you can see that my graph in that case is a decreasing function because it moved from left to right. It keeps on decreasing and going to the downside, so meaning in this case this is a decreasing function. And yeah, they ask you what's the range in that case, what's the range of this graph here, right? So the range is basically y should be less than 0, because remember the range, we said the range is basically the numbers that are included on the graph. So all these numbers above the x-axis are not included. You can see from the sketch that we do not have a function above the y, or rather the x-axis. My function lies below the x-axis, right? It does not cross nor touch the y, nor touch this value here, y is equal to 0. So it means that we cannot include the 0, right? So meaning my function is below the x-axis, and hence that's my range. Then the domain is basically x element of real numbers, or you can write it as x element of from negative infinity to positive infinity, right? Doesn't matter how you write it, as long as you include all the values of x. On a domain, right? I hope that makes sense. So I don't know, comment down below which one is easier for you, right? Analyzing the graph the way I did it on the first graph here, or rather writing all your values, or writing all your values in a box, and then try to make sense of the graph, looking at your box, right? Please comment down below which one is easier for you, so that I can do what you guys prefer on our next videos, right? When we're looking at the hyperbolic functions and the rational functions, right? Okay, so looking at let's look at another example here. Let's say I have y is equal to 2x plus 1 and then minus 3. Okay, this one here is pretty nice, right? So looking at our mother graph will be, or rather our parent graph will be y is equal to 2 raised to the power x, right? So if you can sketch this one here, you notice it will be something that looks like that, right? With our asymptote at y is equal to 0. Okay, now what we're going to do, we're going to apply the reflection and transformation knowledge that we did on our prior videos to sketch this function here from this one here. Then we're going to do the box method. Let's just call it the box method from now. So first of all, here notice that that's our plus c. So our plus c, that means that, okay, I'm shifting the graph how many units? Well, 1 unit to the right or to the left. Well, you have a positive, so that means that from positive, remember we're doing the opposite. If it's positive, that means I'm shifting to the left, so meaning I'll be shifting this graph, well, 1 unit to the left, so meaning I'll be going 1, right? So let's assign this graph here. Okay, you notice that here this is our intercept, so we will have 0 and 1, and let's just put a value of 1 there. Let's say you have 1. When we have 1, we're going to put in 1. Remember our x is 1, so you're going to put 1 there, then we'll get a y value of 2. And let's say here you also have 1, so when you have -1, you will have a half there, right? Hope you can see that. When you have -1, you will have a half. Okay, so now let's see with this function here. Well, remember with this one here, when I'm shifting, I'm going to start with a c. I'm shifting 1 unit to the left, right? I'm shifting 1 unit to the left. So what does that mean? but it means that this graph here will move 1 unit to the left, so meaning whatever happens here at 1 will happen here at 1 minus 1, which is 0. So meaning the 2 will be here at 0. Whatever happened at 0 happened at 0 minus 1, which will happen here at negative 1. I hope that makes sense. Okay, let us try to do that. So what I'm doing first is I'm looking at the C, right? I haven't forgotten about the tree. We'll do the tree when we're done with the C first. I want to explain the C, so you can see that okay, whatever happened at 1 will have, because we are moving to the left, 1 unit to the left, so meaning whatever happened at 1 will happen at 1 minus 1, which is 0. So whatever happened at 1 will happen at 0. So at 1 we had 2, so meaning at 0 we'll have that point there, which is 0 and 2, right? So meaning in that case whatever happened at 0 will happen at 0 minus 1, which is negative 1. So meaning at negative 1, that's when we will have remember at negative 1 we had 1, at 0 we had 1, so meaning at negative 1 we will have whatever happened at 1, which is whatever happened at 0, which is 1. So meaning here we'll have 1, and then you can try 2. So at 2 we have 4. So meaning whatever happened at 2 will happen at 2 minus 1, which is 1. So meaning at 1, at x equal to 1 will be 4. So meaning there we have let me just write it on this side, we'll have 1 and 4, right? And hence my function will be something that looks like that. But that's not my function for now because we still have the 3. So now we have the now that we have the C done with, let us look at the 3. Well, the 3 in that case, we are saying, well, now I'm adding that, I'm subtracting the 3, I'm subtracting all my y values, I'm subtracting all my y values by 3. So what does that mean? Well, that means that I'm shifting this graph 3 units to the downside rail, meaning 1, 2, and then 3, right? I'm shifting 3 units to the downside. That means 1, but rather, because that's 0, that's 2, so meaning 1, 2. Am I doing this right? Well, I'm shifting 3 units to the downside, meaning 1, 2, 3, right? I hope that makes sense. I'm shifting 3 units to the downside, and we are here 1, 2, 3, right? I hope that makes sense. So remember that here we had our isomptome. Let me just use blue, right? Remember that here we have our isomptome. Our isomptome also changes, right? Our isomptome is 0. So what does that mean? Well, everything, all the y values will be affected, right? All the y values, so meaning we'll subtract all the y values by 3, right? So it means now the x will not be affected, so my function, the at 1 will still have 1, but here we'll have 4 minus 3, which in that case is 1. So meaning at 1 we will have 1, right? Remember we're subtracting 3, we're going 3 units down, so meaning we are subtracting 4 with 3, so that we're going 3 units down, right? So we have 1 and 1. Then here the x value will not be affected, so we will still have 0. Then our y will be 2 minus 3, which is negative 1. So meaning my function will be there, right, at 0 and negative 1. Then here again at negative 1 I have 1 minus 3, which is negative 2. So meaning at negative 1 I will have negative 2, right? I have negative 1 and negative 2, and hence at 0, right, at y equal to 0, therefore 0 minus 3 is negative 3. So meaning this isomptome will also move to the negative 3, also move to -3, and hence I have my complete function that will look something like that, where y is equal to -3. Okay, so if I can sketch that graph, or rather let me just remove this red one here. Okay, so this is my function here, my complete function. You can see how I analyze this function with my knowledge to I can remove this one too because we are done with it. These asymptotes. Okay, so you see how I use my knowledge to my knowledge of reflection and transformation of the exponential to sketch the this function here, right? To sketch this function here, it is not that complicated. You just need to draw like your mother graph and then make sense of the function with the knowledge of the reflection and transformation, right? Or if remember math, when you are a mathematician, you have to be lazy, right? That's the whole point of being mathematician. You're making things easier for yourself. So if this one is hard, or rather it will take your time, consume time, so you can just do the box method, right? Just write all your values. Let me just write the function. It was y is equal to 2x plus 1 minus 3, right? Minus 3. You can just do the box method. Make sure that all your values are included, right? All your values are included, especially your intercept, right? So in this case, you are supposed to calculate my x-intercept, and hence to do that, you're going to let y equal to 0. Therefore 0 is equal to 2, and then x plus 1 minus 3, and therefore 2x plus 1 is equal to 3, and hence x plus 1. We're going to introduce the logs. I'm pretty sure we haven't done the logs on this channel, but if you do know the logs, then you're going to say log 3 divided by log 2, and then transpose the 1 over, and hence you will get your answer, your value of x to be 0.6 if you round it off, 0.6 and 0, right? But we're gonna look at the logs, the logarithmic properties and functions, after we have done with the exponential, right? Okay, so now that you're done with that, I can just do my box method where I write my x values, then my y values. Therefore from -3 I have -2, -1, 0, 1, 2 and 3. That's all the values that you need, right? That is all that you need. So whenever I have, and then you just plug these on your calculator, right? I say about 2, and then -3 plus 1 and then minus 3, which will give you -11 over 4. Then you change the -3 to -2, you will get -5 over 2. Then you plug in -1, you will get -2. You plug in 0, you will get -1. You plug in 0, you get -1. Then you plug in 1, you will get 1, right? Then if you plug in 2, then you will get 5, and then if you plug in 3, you will get something like 13, I think. You'll get 13, and then thereafter you just sketch your graph. I'm just gonna sketch my graph. So all I need is that, okay, now I know that this is my horizontal asymptote, so I'm gonna start with that. I'll put my horizontal asymptote there, right? Y is equal to -3, and then I'm just gonna sketch the graph. I can see that, okay, from -3 I can see that, okay, -3 is somewhere there, right? -2 is somewhere there, -1 somewhere there, and 0, 1, 2, 3, 4. So I can see that I keep on increasing as I increase the as I increase my function, right? I keep on increasing, right? Or rather, as I go to positive infinity, my function increases. So meaning I'll have a function that looks something like that, right? I hope that makes sense. So meaning 1, so this would be 1. It's not drawn to scale, but you have 1 there, then 2, 3, and then at 0 I have -1. You can see what I did. It will not join beautifully. Let's just put it here, okay? And then it's not joined to scale. So and then -1, -1. You can see we have that there, and then somewhere there, and then you just combine your function, something like that, right? I hope that makes sense. So 5 divided by 2 is approximately 2,8 something, right? 2,5, yes, and then 11,4 is approximately these numbers approximate to 3, right? They keep on reaching 3, but they will never reach 3, right? They'll approximate to 3, but they will never reach 3, and hence my function will be something like that, right? So either method you'll get your answers as long as you have your y-intercept and your x-intercept and any coordinate that you wish. You can plug in any coordinate that you want on the graph, right? But as long as you have these two coordinates, so here it might be 3 marks, or rather 4. You'll get 1 mark, or rather 2 marks. 2 marks for the coordinates, 1 mark for the shape, and then 1 mark for your asymptote, right? So make sure that you have everything on the graph, especially your coordinates. Your intercept. You have both your intercepts, and then you also have your y, your asymptote, and then you'll get your mark for the shape of the graph, right? I hope that makes sense. And yeah, we're gonna finish off this video here, and yeah, I'll catch you on another one. So on another video we'll be looking at the logs and the inverse functions. You'll be looking at the inverse function, trigonometry, and then yeah, I'll be looking at the other. I'll try to make more videos as possible, as this is a new channel, right? We haven't done much, but yeah, we'll be looking at mostly trigonometry and statistics, because that's mostly the demand, right? Everyone wants statistics and trigonometry, so we'll be looking at that mostly. And then yeah, we'll catch you on another video. That's it for now. I hope that you practice more, and yeah, wish you all the best of luck with your exams, and yeah, have fun on your holidays, June holidays. And yeah, try by all means to rest, but not just rest, and look at your work as well. Spend at least let's say 3 hours a week. I'll catch you on